Hi guys, this is Divyansh Gupta, CAT 1900 Percentiler from IIMpact.mba. For your benefit, I have launched a free course for the CAT 2025 most probable questions. Check the link in description and enroll now for free. Alright folks, so let's start with the number system quiz. Number of ordered triplets xyz such as xyz are distinct prime numbers and xy plus yz plus zx is equal to 120. So I will write this as x times y plus z plus yz is equal to 120. Now, because x, y, z are distinct prime numbers, it is abundantly clear that all three of these cannot be odd because you will have odd into odd plus odd even plus odd into odd, that is odd, which will give you even plus odd, that is an odd number which will never be 120. So one of these will have to be equal to 2. If we put x as 2, we will get 2 into odd plus odd. Rest of the prime numbers all are odd. So odd plus odd, that is even, plus odd into odd, that is odd. So you will get even plus odd is equal to 120, which is again not possible because even plus odd, 2 into even will be even plus odd will be odd. So x cannot be equal to 2, which means let us put one of these, one of the other ones as 2. So you'll get x into 2 plus z plus 2z is equal to 120. Now x and z will have to be odd. So this is odd into 2 plus odd will be odd. Plus 2 into odd, that is even. So you'll get odd plus even is equal to 120, which is an even number, again, which is not possible. So there is no iteration here of x, y, z distinct prime numbers, which will give you this as your answer. So your answer for this question will be 0 triplets. It is not possible at all. Moving on. P represents the set of all natural numbers from 1 to 100, each of which differs from the sum of its factor by 1. Now, the sum of the factor is 1 more than the number itself, which means P is the set of prime numbers in the 1 to 100 range. Because the moment you have for any number, let's say x, you will have 1 and x already as a factor, which means some of the factors will be at least 1 plus x. If there is another factor apart from 1 plus x, this sum will become greater than 1 plus x, so the difference will be greater than 1. So you can only have prime numbers in the set P. Q represents the set of all natural numbers from 1 to 100, each of which is equal to the number of factors. Now, the thing to realize here for Q is that the number of factors for a particular number is going to be much, much lesser than the number itself. So, the only way this can even be possible is when the number, the Q itself, is a very small number. So 1 has only one factor, so this would be part of your answer. 2 has two factors, 1 and 2, so 2 will also be your answer. 3 will have only two factors, 1 and 3, so 3 cannot be your answer. 4 will have three factors, again cannot be your answer. 5 will have two factors, and as you can see now that the difference between the number itself and the number of factors is increasing, so only these two will be part of your set Q. So the largest prime number, because they're asking us for the LCM of the greatest elements of each of the set, the largest prime number in this range is 97 and the largest number in Q is 2. So the LCM will be 2 into 97, which is 194. So the answer for question number 2 is 194. Moving on, number of positive integers which are perfect squares, perfect cubes, or perfect fourth powers. So what we will do is we will first find the perfect squares. That would be cube square root of 10 to the power 6. That is 1000 numbers are there in this range. Both are inclusive, which are perfect squares. Then I will add perfect cubes to this. Now, perfect cubes will be 10 to the power 6 whole cube root. That is 100 perfect cubes are there. Now, because I have already included perfect squares, wouldn't all perfect fourth powers themselves be perfect squares? So I don't need to accommodate for perfect fourth power separately. They are already included in this. Now, this sum will give you 1100. However, we have included perfect sixth powers twice, once as perfect squares and once as perfect cube, because a to the power 6 is also a perfect square. It's a perfect square of a cube, and it is also a perfect cube. It is the perfect cube of a square. So these have been included twice, and I will have to subtract this. So perfect sixth powers have to be subtracted. The number of perfect sixth powers will be 10 to the power 6 raised to the power 1 by 6. So that will be 10. So our answer for this will be 1100 minus 10. That is 1090. So the option number D will be your answer. How we calculated these should be straightforward. You have numbers written like this, and you want to pick the perfect squares here. So square root of 1 is 1, and square root of this is 1000. Between 1 and 1000, every square would be within this range. So you can simply pick this number, and this number itself represents the number of perfect squares that are there, and so on. Moving on. Question number 4. LCM of P and 180 is 720. HCF of P and 150 is 30. Number of possible values of P. So we will write this like this. 150 is 2 into 3 into 5 square. Now the HCF is 30, which is in itself 2 into 3 into 5. Now P will have to have all of these three, otherwise 30 would not be a factor of P. So 2 into 3 into 5 will be there in P. Now, what are the powers that P can take? If the power of 5 is not 1, let's say it is 2, then wouldn't the HCF have 2 as a power? So the value of 5, the power of 5 in P is fixed at 1. It is required because 30 is a factor of P, but it can't be more than 1 because otherwise HCF will change. For 2 and 3, the powers should can be taken as x and y with the constraint that x and y both have to be, greater than equal to 1. They will have to be at least equal to 1. So this is as much info we can get from the HCF statement. Let's move on to the LCM. So 180 is 9, that is 3 square into 20, which is 2 square into 5. 720 is 4 times 180. So this will be 2 to the power 6 into 3 square into 5. Now P I have already taken as 2 to the power x into 3 to the power y into 5. Now clearly, because LCM has 6 powers of 2, which cannot be provided by 180, thus it must be provided by P, which means x is equal to 6. It's a fixed number. Now, about the situation of 3, you already have 3 square in 720, which can hypothetically be accommodated by 3 square in 180, which means your y here need not give you 3 squares. Your p need not have 3 square. It can have 3 to the power 1, it can have 3 to the power 2. But if p has 3 to the power 3, then this power should have been 3, it cannot be 2. So the number LCM could not have been equal to 720. So the only two values of y that you can take is 1 and 2. So correspondingly, you are getting two different combinations, 6 and 1 and 6 and 2. So the number of possible values of P is 2. Moving on, n is 364 into n to the power 5, where n is a positive integer. This has 182 factors. So how many possible values can n assume? So let us look at this. We will have 364 as 2 into 182, which is 91. So 2 into 2 into 91, which is 7 into 13. This is what you already have. 2 square into 7 into 13 into n to the power 5. Now this has 182 factors. Now 182 we have already written as 2 into 7 into 13. So the number of factors of this expression. Now before we move ahead with that, it is abundantly clear that n can only have 2, 7 and 13 as its factors, because otherwise there would be a fourth factor involved, which should have been there in the number of factors expression as well, which it is not. So we will write n as 2 to the power 2 into 7 into 13 into 2 to the power 5x into 7 to the power 5y into 13 to the power 5z. So the number of factors expression will become 3 plus 5x into 2 plus 5y into 2 plus 5z, and this has to be equal to 182, which is 2 into 7 into 13. Now, this expression can never be equal to 2, which means either this or this will have to be equal to 2. So if I take 2 plus 5y as 2, you will get y is equal to 0. Now, can I take 3 plus 5x as 7? Because that will give you x as 4 by 5. But x will have to be an integer. So in this combination, 3 plus 5x cannot be equal to 7. So 3 plus 5x will have to be 13. Or x will have to be equal to 2. Corresponding to this, can 2 plus 5z be equal to 7? Yes, it can. So z equal to 1 will fly. The alternate scenario will be that 2 plus 5z is equal to 2, which is z is equal to 0. Corresponding to that, again 3 plus 5x will have to take 13, or x is equal to 2, and 2 plus 5y will have to take 7, or y is equal to 1. So these are the only two combinations that are possible. So the number of values capital N can assume is 2. So the answer for question number 5 is 2. Moving on. X and y are positive integers, and we have to find the value of 3x minus 2y, given that x square y cube is equal to 256 and x is greater than y. Now, we can write this as x square y cube is equal to 2 to the power 8. Now, clearly x and y can only have 2 as its factors. If there was any other prime number, it should have showed here. So let us take x as 2 to the power a whole square into y, let's take as 2 to the power b whole cube is equal to 2 to the power 8. This will give me a into 2 plus 3 into b as 8. Now a and b will have to be integers. So obviously b being an odd number, either b is equal to 0 and a is equal to 4, or b is equal to 2 or a is equal to 1. These are the only two combinations. After that, a and b will become negative. So corresponding to these, what are the values I will get? If b is equal to 0 and a is equal to 4, I'll get x as 2 to the power 4, that is 16, and y as 2 to the power 0, that is 1. This is satisfied. The second situation will give me x as 2 to the power 1, that is 2, and y as 2 to the power 2, that is 4, but x is greater than y, so this is not allowed. So this is my x comma y. So my answer will be 3 into 16 minus 2 into 1, that is 48, minus 2, that is 46. This would have come by using this situation. All right, moving on. How many natural numbers less than 1000 can be expressed as the difference of two perfect squares in at least one way? So we are saying that a square minus b square is equal to capital N. This means a minus b into a plus b is equal to capital N. So now let us talk about this. If a and b are both odd, what will be the sign of, or what will be the parity of capital N? This will give you odd minus odd into odd plus odd, that is even but with a power of 4. This should be a multiple of 4, because you will get this also as this will have a power of 2 and this will have a power of 2. So n will have two powers of 2 at least. If one of this is even, the other one is odd, you will get n as an odd number. If both of these are even, you will get even, and again 4 as one of the factors of capital N, because even minus even will give you an even number, so 2 into something, and even plus even will give you 2 into something. So you will have 2 into 2, that is 4 there. So the key here to the values of N is that either N is odd, or if n is even, then it should be a multiple of 4. It cannot be just a multiple of 2. So your answer will include 500 odd numbers, and 1000 by 4, that will give you 250 numbers in the 1 to 1000 range, which are multiples of 4. However, 1000 is not included because you have less than. So you will do 1 minus 1 here. You will exclude 1000 from your answer. So that will become 249. So the answer for this will become 749, or option B. Moving on, a number n square is such that exactly three of its factor are less than n. So if we were writing n square, we will get a into b, c into d, e into f, and n into n. Three factors are less than n, which means three factors are also greater than n, which means n square has seven factors. So what are the numbers that can have seven factors and also be, square? The only possible way is if it is p to the power 6. So n square is actually p to the power 6, which means n is actually a prime number whole cube, which means n cube is prime number whole to the power 9. And the number of factors of this will be 9 plus 1. That is 10. So the answer for question number 8 is 10. This fact, how we arrived from 7 factors to p to the power 6, was simplified because when I said n square has only 7 factors, which means when I write the number of factors expression for a number which has 7 factors, I would have to write 1 plus 0 into 6 plus 1, because 7 is a prime number, so it will have to be 1 into 7, which means there is only one prime number, and that has to be a perfect sixth power, so raised to a power 6. Moving on, question number 9. A plane is scheduled to take off every 35 minutes starting from 8. A plane is scheduled to land every 20 minutes starting from 8:05. Whenever these takeoff and landing occur at the same time, a landing plane will be delayed by 3 minutes and the subsequent ones will not be delayed. So how many planes that are scheduled to land between this will get delayed? So basically we have to find that this series of 35 minutes and this series of 20 minutes, how many times they overlap between 8 a.m. to 9:30 p.m. So we will first try and find the first term here, the first time this coincides. So because this is starting at 8:05 and every 20 minutes a plane will land, the landing times will always have 5, you know, uh, in its minutes configuration. So it will be 15, 25, 35, 45, but it will never have a zero there. The configuration of 8, the configuration of takeoff will change. 8:35 and then it will become 9:10. So 50, then next will become 9:45. So the I will take 8 plus 35 into 3, which is going to be 105 minutes. And can I get from 8:05 to 105? Yes, I can by making 5 jumps. So that will give me 100 plus 5, that is 105. So at 8 plus 105 minutes or at 9:45, this situation will happen for the first time. After that, after 9:45, this situation will occur at 35 into 4, which can be written as 20 into 7. So I basically just found the LCM of 35 and 20, which is going to be 140. So after this, I can go ahead with this. This is going to be 12 hours plus 15 minus 15 minutes. So this is going to be 12 into 60, that is 720 minus 15, that is 705 minutes. And I have to break this 705 minutes into blocks of 140. At every 140th minute, you will have one coinciding takeoff and landing. So 705 by 140 will give me 5 plus this 945. So I will have 5 plus 1, that is 6 such instances. So this is actually a question of LCM. They just tried to complicate it by introducing hours and minutes. So you can convert this into the entire duration as minutes and solve further. All right, so let's move on to question number 10. Area of a rectangle is 675. So length into breadth is equal to 675. Length is given to me as greater than the breadth, which is also the convention. Uh, how many rectangles are there for which at least one of the dimensions is not a multiple of 3 and at least one of the dimensions is not a multiple of 5? So let me factorize this. I will get 25 into 27, which is 5 square 3 cube. Now this has to be equal to length into breadth. Now I do not want both of them to have 5 as a factor. So I can't split this 5 square between 5 between length and breadth. So this 5 square will be there together as a whole in one of them, and similarly 3 cube will also be as a whole in one of them. So the distributions that you can have is 5 square 3 cube into 1, or 1 into 5 square 3 cube, or 5 square 3 cube, or 3 cube 5 square. This is length and breadth. Now because obviously this is given to us, length is greater than breadth, so this one is out and this one is out. 25 is less than 27. So the only two options will be either this or this. So total two possible values. Moving on. If k is a natural number and then we have this quadratic into quadratic is equal to 240. Now, obviously, this is not a quadratic question for us because k is defined as a natural number. So I should try and do something like product of numbers is equal to an integer 240. These numbers can be factorized. This is k minus 3 into k minus 7, and this is k minus 4 into k minus 5. So what it looks like to me is there are three consecutive numbers that are getting multiplied to each other, and then there is also a smaller number k minus 7. So let us now break 240. I want to arrive at product of three consecutive numbers. So I will first write this as 12 into 20. Now these numbers I will have to further break this down. I will write this as 12 into 10 into 2. I can break this as 6 into 2 and this as 5 into 2. So I can see 6 and 5 being consecutive. Then 4 would also satisfy that pattern and I'll be left with 2. So if I take this as 6, 5, 4 and this as 2, I will get my product as 240. And is there a same value of k? This is giving 9, this is giving k as 9, k minus 4 is equal to 5. This is giving k as 9 and this is giving k as 9. So my answer for this is k is equal to 9. Moving on, a natural number n has 7 factors greater than root n. Root n is also a natural number, which means that if I write the factorization of n into two factors, I'll get a into b, I'll get such 7 pairs, and then I will get root n into root n, which means as a whole will have 7 factors greater than root n, 7 factors less than root n, and root n. So n has 15 factors. For n to have 15 factors, it could either be of the format 3 into 5 or 1 into 15. This will give you the number as n is equal to p1 square p2 to the power 4, and this one will give me p1 to the power 14. So n to the power 3 by 2 will become p1 cube into p2 to the power 6, or p1 to the power 21. This will have 21 plus 1, that is 22 factors, and this one will have 3 plus 1 into 6 plus 1 factors, which is 4 into 7, that is 28. So the answer for question number 12 will be 28. So m is a positive integer greater than 4 and n is equal to m square minus m. So first let us factorize this. We want to find the greatest number that will always divide this. So this is n into n square minus 6n plus 8, or n into n minus 2 into n minus 4. Now let us look at this. N is m square minus m. So n is going to be m into m minus 1, or n will be an even number because it is the product of two consecutive numbers. Now, if n is an even number, and if we look at this, n, then n minus 2, then n minus 4. If n is only divisible by 2 and not by 4, then n minus 2 will have to be divisible by 4. And n minus 4 will have to be divisible by 2 and not 4. You can also have this situation, that n is divisible by 4, which would mean n minus 4 is divisible by 4 and n minus 2 is only divisible by 2. So which means that in the worst case, you are going to get 2 into 4 into 2, that is 2 to the power 4, or 16 as a factor of n into n minus 2 into n minus 4. Secondly, these are three consecutive even numbers, which means that they will have one power of 3 at least. One of them will be a multiple of 3. And you can look at this very carefully. 4, 6, 8. 6 is going to be, having 3. 6, 8, 10. 6 is going to have 3. 8, 10, 12. So 6 got eliminated. The next number that got added here, it had a 3 in its, prime factorization. So you will have at least one power of 3 as well. So 16 into 3, that is 48. These are assured regardless of what your number is. So answer will be option number A. Moving on, product of all the numbers of n is equal to n to the power 8, then which of the following cannot be a factor of n? So let us look at this. If I break down n into, two numbers, by writing its factors, a into b will give me n, which means there should be 8 such rows, which would mean that n will have 16 factors. Now, if n has 16 factors, the factors of n themselves cannot have more than 16 factors. Correct? Because each option, if I say that this is a factor of n, then every factor of this would also be a factor of n. So let us look at this. 2 square into 3 to the power 1 into 5 to the power 1 will have 3 into 2 into 2, that is 12 factors. So this is okay. This is less than 16. This is 4 into 3, that is again 12. I am okay with this. This is less than 16. This is 7 into 2, that is 14, which is again less than 16. And what is this? 3 into 3 into 2, which is 18, which is greater than 16. So you cannot have this as a factor of n because this itself has 18 factors. So how will n has only 16 factors? The factor of a factor is also a factor. So the answer will be option number D. This cannot be true. Moving on, largest number which leaves remainder of 4, 6, and 2 when it divides these numbers respectively. So, which means they are asking us for the HCF of 460 minus 4, that is 456, 690 minus 6, which is 684, and 990 minus 2, which is 988. So, we have to find the HCF of these three numbers. I can further simplify this. I can take a difference here. I'll get 14 minus 6, that is 8. Then I will have 7 minus 5, that is 2. So this is 228. The difference here is 228 and the difference here will be 403. So I can find the LCM of the HCF of these two numbers, 228 and 304. So this uses the concept that the difference can be used to find the HCF. So this is, if I divide this by 4, this is 4 into uh, 50 uh, 7, and this is 304. So this is 4 into 76. Now, furthermore, this is 4 into 19 into 3, and this is 4 into 19 into 4, which means 4 into 19 is the HCF of these two numbers, which means it's the HCF of these three numbers. So, answer will be 4 into 19, that is 76. Moving on, number of integral values of a k such that k is in this range such that the product k minus 1 factorial is not divisible by k. Now the reasoning for this is very straightforward. If k is a composite number, if k can be broken down into two numbers that are smaller than it, uh, then those two smaller numbers would be present in k minus 1 factorial because k minus 1 factorial includes all the numbers that are smaller than k, which means k will have to be a prime number. So I will count the prime numbers that k can take. So that is 2, 3, 5, 7, 11, 13, 17, 19, 23, and then 29. So these are 10 values. Apart from this, in this particular situation, there is an exception. K is equal to 4 because 3 factorial by 4 will be 6 by 4, which is again not divisible. So this is the only, exception to this rule. Otherwise, K will have to be a prime number itself. So your answer will be 10 plus 1, that is 11. So option number C. Moving on. Ritu came across four numbers A, B, C, D. A has 15 factors, B has 25 factors, C has 27 factors, and D has 40 factors. Curious to find out which one could possibly be a perfect cube. So we have to find which one can be a perfect cube. So 15 would mean that A is either of the form P1 square into P2 to the power 4 or P1 to the power 14. Now, both of these numbers are not perfect squares. So A as an answer is out. Moving on, 25 means that P1 to the power 24 or the other one, but I'm not interested there because this is a perfect cube. So B can possibly be a perfect cube. So it comes down to C and D. Technically, I didn't have to check for B because the remaining options have B. So let's check for C and D. If I go for D first, or D will have probably have more factors. So let's go with C. C can be written as P1 to the power 26 or P1 square into P2 to the power 8. This will give you 2 plus 1 into 8 plus 1 factors. Or it can be written as P1 square, P2 square, P3 square. So this will give you 3 into 3 into 3 factors. I don't think there are other iterations possible and none of these are perfect cubes. So C is also not possible, which means option number D will be our answer. And if you do want to further check, if D has 40 factors, D can be written as either P1 to the power 39 or because we want to break it into perfect cube, I'll write this as 4 into 10 and 4 will give me 3 and 9. So P1 to the power 3 and P2 to the power 9. This will have 3 plus 1 into 9 plus 1 factors, which is 40, and this is also a perfect cube. So your answer will be B and D. Moving on, how many positive integral solutions exist for a square minus b square is equal to 448? This gives me a minus b into a plus b is equal to 448, which is an even number, which means this should be, a minus b and a plus b both will be even, correct? So 448, I will write this as 4 into 1, 1, 2. So this 4 will get distributed equally, 2 to this and 2 to this. There's no argument there. So I can further reduce my question to x minus y into x plus y is equal to 112. And I will have no constraints here. I don't care which one is even, which one is odd. So now I can break this down as this is 56 into 2. 56 is 7 into 8, which is 2 cube. And I already have this. So 7 into 2 to the power 4, which means the number of ways the number of factors here will be 1 plus 1 into 4 plus 1, which is 10. So I can have 10 factors, which mean I can write it as a product of two numbers in 10 by 2, that is 5 ways. So answer for question number 19 will be option B. So this trick of giving 2 to each of the factors, it is highly useful because otherwise you would have found number of factors for this for 448 and then you would have to individually check in which situation a and b will come integer or not. Doing this distribution first allowed us to just forego of that situations. Moving on, some of the smallest five numbers having exactly 12 factors, including one and number itself. So you want to have 12 factors, which means you can have either this as your format, or so let's first write 12 as 12 into 1, or you will have 3 into 4, or 3 into 2 into 2, or 6 into 2. These are the four ways in which you can write 12. So this would give you p1 to the power 11. This will give you p1 square p2 to the power 3. This will give you p1 square p2 p3, and this will give you p1 to the power 5 into p2. Now, once I have this, I can start finding the smallest five numbers. This will be 2 to the power 11. This is going to be obnoxiously high, so I'm safe here. This will be the smallest will be 3 square 2 cube. The smallest here will be 2 square into 3 into 5. And the smallest here will be 2 to the power 5 into 3. So 2 to the power 5 will be 32, and 32 into 3, that is 96 is the smallest here. The smallest here is 4 into 15, that is 60, and the smallest here is 9 into 8, that is 72. So the absolute smallest is 60, then 72. After that, we can, probably go and check for a couple more down these, lines. So this would be 2 to the power 5 into 5. This would be the next smallest. That would be 32 into 5. That is 160. Here, what will we get if I put this as 3 square into 2 into 5? That is 9 into 2, 18 into 5. That is 90. I could have also taken 5 square into 2 into 3, which would have given me 25 into 6 or 150. So both of these are lower than this 160. So I feel okay. I could have also taken 2 square into 3 into 7, which would have been 21 into 4, which is 84. I think we have exhausted this. We have got sufficient numbers. Here, the next number would have been 2 square 3 cube, which would have been 108. So, if I were to find the smallest numbers, I will get 60, then 72, then 90, then 90, then 84, and then finally 96. So my answer will be 72 plus 60 plus 90 plus 84 plus 96. So this will be this plus this is 180, this is 270, this is 270 plus 60, that is 330, and this is 330 plus 72, that is 402. So answer for question number 20 will be 402. So while this question looks easy, but you will have to make all these sort of iterations to ensure. We could have easily missed 84 if we didn't think of including 7 in the prime factors. All right, moving on. This is a very similar question to cat. A is the smallest possible integer such that 702 is a factor of 2028. So we will have to factorize these 702 and 2028. This is 4 into 507, which can further be written as 3 into 1, and then you will have 20, that is 6, and then 169. So this is 4 into 3 into 13 square, or 2 square into 3 into 13 square. This is 702. This is divisible by 9. So I'll write this as 3 square into. So if I divide this by 9, I will get mm, I'll get 7, and then I'll be left with 72. So that is 8. 3 square into 78, and 78 can be written as 13 into 6. So 13 into 2 into 3. So this is 3 cube 13 into 2. This is 2 square 3 into 13 square. So let me write this in organized way. 3 cube into 13. This is 702, and this is 2 square 3 into 13 square. Now a is the smallest positive integer such that 702 is a factor of 2028 to the power a. This is 2028. Now to divide this by 702, everything is in order for 2 and 13, no problem, but I will have 3 powers of 3 in 702, which I need to get here, which means a is going to be equal to 3, which makes 2028 to the power a as 2 to the power 6, 3 cube into 13 to the power 6. Now this I want to be a factor of some power of 702, which is 2 into 3 cube into 13. Obviously, the limiting case here is going to be 2 and 13, because the denominator has 6 powers of 2 and 13, but 702 itself has only 2 and 30, only 1 powers of each. So I should raise this to 6. So this will become 18, and this will become 6. This would be divisible by 2028 to the power a. So a is equal to 3 and b is equal to 6, which means a plus a into b is going to be 18. Moving on. So Fn is 1 factorial, 2 factorial, and so on, and we have to find the remainder when this is divided by 100. So the best way to do this is to realize that the series that is given to you is n plus 1 factorial minus n factorial, because when you take n factorial common here, you will be left with n plus 1 minus 1, which is n into n factorial, which is exactly what is given to you. So if I start writing this as n plus 1 factorial minus n factorial, I'll get 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial, and so on until it will keep on going until finally n plus 1 factorial minus n factorial. This will cancel out, this will cancel out. So only minus 1 factorial and n plus 1 factorial will remain, which means f of n is n plus 1 factorial minus 1. So f of 117 is going to be 118 factorial minus 1 plus this, which will be 112 factorial minus 1. And this is going to be divided by 100. Both of these have 100 in its representation, so there is going to be no remainder here. The only remainder that is going to come is from here, minus 1 and minus 1, which is minus 2 remainder or 98 as a remainder. Moving on, x, y, z are odd integers. Which of the following statement is not true? All right, so let's do it in a, very fast way. Odd, odd, odd. Sum will be odd into odd, odd, odd. So odd into odd into odd into odd will be odd. So this will be true, so not our answer. Odd plus odd, which is odd, into odd plus even plus odd, which is even. So odd into even will be even, not our answer. Odd plus odd, which is odd, into a square of an odd number. This is even plus odd, that is odd. So odd into odd square will be odd. So not our answer. We can finally check for this. Even plus even will give me odd, and odd into odd will be odd, plus even will be odd. Odd into odd cannot be even. So this is not true, which means this is my answer.